Please welcome the HP Director of HyperScale Engineering, Curt Belusar.
So this morning, I think we had a slide that was put up with vendors 1, 2, and 3 up on the screen. I think HP is fortunate enough to be vendor number 1. I'll come back to that in a little bit, but we're number 1 in density optimized cloud server shipments, according to IDC. For HP, leading the industry involves being on top in 2 areas, and they are driving standards and innovation. It's critical to drive out industry standards so that we can provide a better experience for the customer and through the value chain, all the way from manufacturing the server to delivering it to the customer. We also believe that it is critical to innovate. You've got to innovate to be able to optimize performance per watt per dollar and bring that value to the customer. Industry standards have been around since day number 1 of x86 servers. You know, these started off with simple specifications like PCI, ESA, SCSI, and basically interconnects for things that you put in the server. They quickly transitioned to things like management, different rack level specs, fabric and interconnect specs, and even data center level specs. Today, though, with the explosion of the Internet of Things, and this whole community that we have here, we're starting to see open specs. OpenStack, OpenFlow for networking, and open compute that we're here to talk about today. It's important to know that for successful specs will go and provide standards for the industry, but they also will lead us to innovate. And this innovation is critical. The two need to go together. It needs to be a symbiotic relationship. So our key for leading the industry is recognizing the trends, creating the right standards, and then innovating. In May of 2012, it was here at the Open Compute Summit, HP rolled out some servers that we have that were lined up against these industry standard specifications. The first server that we brought out was what we called the Coyote server internally, but this server was lined up against the initial Open Compute specification. One of the things that we at HP really did appreciate about Open Compute and think that it's brought to the community and challenged us on is it allowed us to go create some more efficient power supplies than what we had at the time. You know, we brought out auto-ranging power supplies that were able to handle everything from standard high line up to 277 volts. But more importantly, we had to start concentrating on things that we'd never had to worry about before with large volume scale deployments, things like total harmonic distortion and phase balancing. And these are some of the great things that this has brought to the industry and that it has challenged us to go do. We also, at that time, were starting to work on our next Open Compute server. And you can see the ProLiant 2150 is listed up there. It was a 2-socket Xeon system that was designed in a tray, had 3 across, and this was designed for OpenRack. And so that met the OpenRack standard, used the same power distribution system that comes with OpenRack, and allowed HP to provide a power-efficient and dense server that operated in the OpenRack environment. I'm also proud to say that HP has been partnering with Microsoft, and many of you probably saw the announcement that Microsoft brought out the cloud server specification. HP has been working for quite a while now on making sure that we can roll out servers that match up with that specification. And we're actually working on we have both the first generation and we actually have a second generation of that server environment. But these servers bring the optimal in density and power efficiency. You can go read about it on Microsoft specifications, but they run Fabric through the back, and so you've got basically an I/O channel that connects all those servers together. And we're glad to be a part of that announcement with Microsoft, and you can actually stop by our booth and see that server. Next, I want to stop for a moment and talk about innovation. At HP, innovation is very critical to what we do, and I want to bring out a couple of proof points of things that we're doing to go extend beyond and further innovate around power efficiency and cooling. So for those of you who are not familiar with NREL's Peregrine system, that's the National Renewable Energy Laboratory system that they have in Colorado. This is a system that is very dense. It's basically taking warm water and it's using warm water to cool the servers. The interesting thought with this is, what do we do with that warm water once we're done? Most folks would call it wastewater or waste energy. And the reason why we call it waste energy, honestly, is because we're not smart enough to figure out what to do with it. So we kind of feed it around, try to figure out how to cool it. At NREL, they're actually doing some very unique things. They're taking that warm water, they're actually using it to heat the building that the data center is in, and this includes in offices, so it's a large office building as well. They had a boiler that they built that building, they actually turned it off, and they're using this to provide the heat for the building. They're also taking the waste heat and they're piping it around, and they're using it to melt snow on the sidewalks there on NREL's campus. This is one example. We all talk about PUE. It's important to strive for data centers that have low PUE, but PUE may not actually be the best measurement out there. We may need to look at new measurements that will go take into account reusable energy. So maybe we need something that actually takes PUE and subtracts out energy that you're putting back or that you're using to go do other things. So food for thought, but this is an area where HP thinks it's very important, since we're just burning megawatts of power out there in the world. I think it was 3 to 4% rising of the world's energy is being used to power data centers, and that statistic is only going to get worse. We need to figure out how to be more efficient with the energy that we are burning on our IT equipment. The other piece of innovation that I want to point out is Moonshot. So Moonshot is HP's system that we've developed that basically houses an ecosystem of SoCs, or system on a chips. And you can read the quote there, but basically it's the first time that somebody has gone and created an ecosystem that goes and fits up to 180 servers in a 4.3U space. That means in a rack, we can get over 1,800 servers per rack. These servers are some of the most energy efficient servers in the world. These are servers that are based off of SoCs. These are the same chips that you'll find in your phone. That's one of the transitions that's taking place right now in the industry, and it's important to understand. It's estimated that by 2020, we will have 30 billion mobile devices out there. That's going to drive a change in economics in terms of the type of processor and which processors we use. And furthermore, these processors are designed to be extremely power efficient. I don't know how many of you look at the number of mobile devices that you have in your household. If I think of the 4 people kind of in my small family unit, we actually have more than 4 phones. We've got 5 phones per 4 people. I don't know how many of you are that way. And that includes my 10-year-old, who can download more data than I can in a matter of 10 minutes. That trend is just going to continue. If you go and you look, another study that I did is I went and I looked at some of the folks that I work with and asked them, how many devices do you have connected up at home? One guy actually looked at his router. He had 40 devices in his house connected at home. Again, that trend is just going to continue. I don't know how many of you read the recent article on smart appliances that were turned into, thing bots and used to go create problems out on the internet. But it just shows that this trend with mobile devices is going to continue. The volume economics are going to get there for these type of processors. And HP's Moonshot system is one of the systems that takes advantage of these extremely power-efficient devices and fits them in a very dense area. So I invite you all to stop by our booth, which is B10, take a look at the Moonshot system, and take a look at the open compute servers that we have there. And I look forward to seeing you all there at the booth. Thanks.